This demonstrator is the result of the activities performed in the first year of the ARISE EU project. The aim of the project is to establish open source and standard-based all-in-one middleware for industrial robotic applications. Here we can see the consortium of this project led by Cartif, and in this project POLIMI Industry 4.0 lab acts as a testing and experimentation facility in order to act as a test bed for the tools that are being developed in ARISE project. So our testing and experimentation facility consists of a flexible production line and equipment in order to provide a playground for testing of new technologies in different sectors such as robotics and manufacturing. And in this project we are mainly under the topic of human-centric zero-defect manufacturing. So in this project, POLIMI TEF is responsible for two challenges, and in this demonstrator we are talking about the human-robot interaction for improvement of ergonomics in high-precision tasks, which is the eighth challenge of this project. In order to address the challenge, we have a dedicated use case which is titled workpiece holder, and with this use case we intend to respect the ergonomy of the operator, taking advantage of the collaborative robot to hold the workpiece while the operator is performing a dismantling task of printed circuit boards, so that the operator will have less burden for keeping the workpiece while it's performing its task. In addition, we are going to monitor the posture of the operator, leveraging vision systems so that we can warn him if it's in the poor posture. And we receive also feedbacks from the operator if he prefers to have the workpiece in a position that he can inform the cobot, and the robot should follow his commands. The software and hardware that are involved in this use case, you can see here. We have used VOSC for a speech recognition task of the operator. We are leveraging on ARISE Vulcanexus toolset, which with the main core of ROS2, enabling us for communication among the devices. We are using the OLAMA large language model for the interpretation of the human commands and intents, as well as the ROS4HRI. ROS4HRI is also used in this use case as one of the main tools of the project, as a framework and a standard for social interactions, skeleton tracking, and large language model for understanding of intent of the operator. As well as the hardwares are concerned, we are using the universal robot, collaborative robot equipped with ROS2 driver for the assisting task, and inter-real-sense camera for monitoring of the posture of the operator and also the workspace. In the first step, we have implemented the and adopted the ROS4HRI library on our inter-real-sense camera in order to track and extract the skeleton of the operator, This library leverages on a unified robot description file in order to represent the skeleton of the human based on the height of the operator. Having this data from the skeleton, we can then analyze the data for ergonomic assessment. Here we have used the rapid upper limb assessment as a method for posture assessment, which gives relative scores to different parts of the body of the operator. And we are lively monitoring the posture of the operator while he is performing his task, and we can warn him in case of a poor posture. So as you can see in the video, the ROS4 HRI completely follows the skeleton and the posture of the operator, and then we can retrieve that data for computational purposes. And also we have defined a graphical user interface for more intuitive interaction of human and robot. So here we have created also a notification system which is based on LLM to support the more intuitive human-robot interaction. So the operator can send commands either via voice or via text by this graphical user interface to the robot, and also he can, in the text box below, can see the perception of the robot from that command, so that he can be sure that what the robot is going to execute and be aware of the action of the robot. So in the video you can see that the GUI is offering that he has a poor posture and he has to improve it, and sends the notification for asking the operator to select the better position. So the GUI acts as shows the perception of the robot and also the notification for the warning. In this phase we have tried to convert the command of the operator for the robot. So in the video at the left side you can see that the operator asked the robot for moving up, and at the same time the robot is listening to the operator and will print the perception that he has from the command of the operator, which is correct, and is moving the robot up. While in this slide you can see the real execution of this command, that the robot moves up, and the robot also will publish the intent and perception that it has from the command of the operator. So in conclusion, by using the ARISE enablers, this use case could assist us for assessing the postural posture of the operator while performing its task. As in addition, we could leverage on ROS2 capabilities for communication between vision system and the robot to give notifications and warnings based on ROS and large language models. So in the next phases we will try to incorporate also a better assessment of RULA with the ROS4HRI, with the help of ROS4HRI and other tools of the project, and we will continuously try to address the challenges that has been defined.